Hi everybody, welcome to section 5.3, solving multi-step inequalities. In sections 5.1 and 5.2 we solved one-step inequalities. Now these are going to feel just like solving multi-step equations, only we're going to have to watch that inequality, less than or greater than. So let's go through some steps and then we'll do a couple examples. So first of all, if you've got parentheses, use the distributive property. It's kind of like common sense at this point because we did so much with equations. Then if you do have on either side, if you cover up one side of the equation, look for like terms. If you cover up the other side of the inequality, look for like terms. Numbers or variables can be combined when they are on the same side of the inequality, just like we can do that with equations. So if they're on the same side, you just do the math. If they're on opposite sides of the inequality, then we're going to use inverse operations. So inverse operations will probably start off by adding and subtracting, usually, and we'll probably multiply and divide next. But we're looking to isolate the variable. That's always our goal, is to get the variable on its own. And don't forget our number one top priority, flip the inequality if you multiply or divide by a negative number. Adding or subtracting, nothing changes, but if you multiply or divide by a negative, you have to flip over your inequality. And you know you're done when you are sure the variable is isolated and positive on one side of the inequality. These are all the same rules that we use for equations. We're just using less than or greater than. So distributive property if needed. Combine like terms if you have them, if you can. Start using inverse operations when things are on opposite sides. Remember, draw that line down the inequality. If you add 3x on one side, you have to add 3x on the other side. And then finish off the problem to isolate the variable. Make sure that it is positive. So let's do a problem like number 3. Notice it does say solve each inequality, check if needed, graph it on a number line. I think we've got that down from section 5.1 and 5.2. So in problem number 3, I've got an x plus 7 all over 3 is greater than negative 4. You know how I always say usually we add or subtract first. In order to get to that x and the x plus 7, this is all part of a giant fraction. We're going to have to take care of that fraction first. So we're going to times by 3 on both sides. That 3 is positive, so we don't have to worry about switching the inequality at all. And when I times, I get a negative 12. Feel free to put that line down if you want. That reminds you to make sure that you do the same thing on both sides of that line. Last step, if I want to get the x by itself, I'm going to subtract 7. Subtract 7. Since it's a subtract, not a multiply or divide, I don't have to worry about flipping my inequality. I'm left with x is greater than negative 19. So this checking the solution thing, any number that is greater than negative 19 will give me a true statement. So let's say I put in a negative 22. Well, let's try negative 20, how about? Because, no, sorry, let me do that right. Let's put in a negative 18. It's got to be greater than, right? I'm on the negative side. So if I put in a negative 18 for that x and test it, negative 18 plus 7 is negative 11. Divide that by 3. It comes out to like negative 3 2/3 or something like that. Is negative 3 2/3 greater than negative 4? Is negative 3 2/3 farther to the right on the number line? It is, so this is a true statement. So you can check it. I'm not going to go through the check step every time, but you can check it if you need to. And of course, if we're going to sketch that on a number line, I'm going to put a negative 19, a negative 18. Negative 19, get an open or a closed circle. And which way should my arrow go? Open and going to the right because it's greater than. Number 4, I've got some parentheses in this problem, so I'm going to distribute. So when I distribute, I get a 12t minus 20 greater than or equal to 8t plus 3. Feel free to put that line down the middle if you like. If I look at either side of that equation, or if that inequality, I don't have any like terms. All I've got on the left is a 12t and a minus 20. Those are not like terms. All I've got on the right is an 8t and a plus 3. Those are not like terms. So I'm going to get all the variables on the left, all the numbers on the right. I always start with the variables, so I would start by getting this 8t out of here. So that means I've got a 12t minus 8t is 4t minus 20 equals 3. Now I'm going to get all my numbers to the right-hand side. So I'm going to add 20, add 20. So I get 4t greater than or equal to 23. I'm going to go ahead and finish that problem by dividing by a positive 4. So t is greater than or equal to 5.75, 5 3/4, 23/4, however you want to put that. I'm not going to be particular on some of these. Right? So there's a couple examples of multi-step. It should feel very much like multi-step equations. Nothing's different except for that remembering to flip the inequality if you multiply or divide by a negative. There are a couple other possible situations that could happen. You could have all real numbers. That's that capital R with the double line on it. When you solve the inequality and you get a true statement, it's true. Now, when we did that with equations, we would get something like -2 equals -2, and that's true. But if we're looking with inequalities, we could get something like 0 is greater than -3. That is a true statement, which means that all real numbers. We have no variables left. I better put that. You solve the inequality, you get a true statement, no variables. Any number you use for x will make the inequality true. Empty set means when you solve the inequality, you get a false statement, and of course, there are no variables left here either. Like maybe your 3x and your 3x subtracted out of both sides. Any number you use for x will never make the inequality true. When we were dealing with equations, we might have gotten something like 5 equals 8. That's definitely a false statement. When we're dealing with inequalities and we're looking for, oh, by the way, empty set is our no solution symbol. When we're dealing with inequalities and we're looking for a false statement, we might have something like 2 is greater than 1. Sorry, 2 is less than 1. I wrote it right. 2 is less than 1 is a false statement. Therefore, there is no solution, there's no variables left, and we have a false statement. So let's do one more example. Let's see what kind of business I've got here. Let's do this problem number 10, because it's busy and a lot of stuff is happening. So problem number 10, we'll skip the other ones. There's always extra practice problems for you to do. So there's a lot happening here. I noticed, first of all, parentheses, so I know I'm going to do distributive property. If you want to make this a plus a -3, so you remember when you distribute to use a -3, this first 3 comes straight down. So -3 times b is a negative or minus 3b. -3 times -2 is a plus 6. I'm going to bring my inequality straight down. So less than. Here I've got a 13 again. And if you want to make that a plus a negative, so you remember when you distribute, do the same thing. So a -3 times b is a minus or -3b. -3 times -6 is a plus 18. So now here's one of those examples where we've got like terms. If I just look on that left-hand side of the equation, I've got a 3, I've got a minus 3b, and I've got a plus 6. That is a math problem that we can do. 3 plus 6 is 9, and it's positive. My -3b didn't change. So I combined these two like terms to get that 9. On the other side of the equation, we also have some like terms. I've got a 13, I've got a -3b, but I've got an 18 as well. So I can combine these two like terms, and I've got a 31. My board's a little crazy. That negative 3b didn't change at all. That 31 was a positive, and I'll bring my inequality right down. So I combine like terms just to make the problem a little bit easier, simpler, less steps to solve. So now my strategy is always to get all my variables on the left, numbers on the right. If I want to get this minus 3b out of here, I would add 3b and add 3b. So this one crosses out. That's good, right? I've still got a 31 left. Over here, what happens to my other sets of b's? These guys also cross out. I'm just left with a 9. We've got no variables left. So we've got two options. No variables means either all reals or no solution. In this case, we're going to look to see what we've got left. We've got 9 is less than 31. True statement, right? 9 is less than 31. So since this is true, we know that this solution is any real number. We could put any number in for B, and we would always have a true statement. So all reals is true. No solution would be false. If it was opposite, if it said 9 is greater than 31, that is not true. So we would have no solution for that one. So lots of reviewing from solving equations and then just adding that extra inequality. We didn't do any examples where we had to flip over the inequality, so we'll make sure we do some in class when we talk about this. All right, lesson summary. How do you know if an inequality has no solution or all reals as a solution? Just talked about that, right? So that should be fresh. And solve this inequality. Notice it's got distributive property written all over it for your first step, and then you can start getting all your variables to the left, numbers to the right. That is it for section 5.3. Have a great day. We'll talk to you. Make sure you bring any questions with you so we can clear things up.